be going really fast through a lot of stuff, so I am sorry if I lose you a little bit of part of the way. The good news is it's getting recorded, so you can always go back and watch it later. And I especially apologize to the people whose first language is not English, because I'll be going fast, so hopefully I don't lose you in translation. The reason why I want to pack a bunch of content in here is because there's a lot to talk about. And I think this is a especially important moment like today, right now in, I think it's like what, late April? 2 months ahead of IPFS Camp, where I kind of want to call this community, the libp2p community, to make some significant kind of like concerted efforts towards community growth. And I want us to use IPFS Camp as a really good venue for that. So all of that is going to sort of build towards this. So I want to talk about first the long-term libp2p vision. We got an awesome intro at the beginning of the conference, at the beginning of the libp2p track yesterday that gave a sense of what the project is and so on. So I won't go in detail into the stack, but I want to give you the broader context of libp2p from a macro view. So as we know, it's a modular peer-to-peer networking stack. There's a lot of different components that add up to that. It got refactored out of IPFS historically. And kind of the goal there was to make sure that other projects that wanted to leverage peer-to-peer systems didn't have to start from scratch. When we started IPFS, we basically had to start our own entire implementation of everything from scratch because the peer-to-peer systems of the past had not done this kind of work of refactoring their networking stack into something reusable. So that goal was, that was a purpose of creating the libp2p project. And the good news is that it's been massively successful. There's a huge ecosystem of implementations and users. And you can think of like the direct adopters of libp2p and then their downstream ecosystems. And so there's an enormous amount of people using and depending on libp2p. And this is just a small snapshot. So I think once the Ethereum merge happens later in the year, it's going to be kind of like really grow in terms of impact. But already this is probably underestimating it, given I only have a few of the sort of end user ecosystem snapshots. So it's one of the most kind of important projects in the entirety of Web3. But you perhaps wouldn't think of that given the sort of like size of the footprint and profile of libp2p as a project. There's a ton of like really good material and really good content on the web. You can find lots of videos and lots of really valuable talks that kind of go into detail. And you can find this like awesome visionary roadmap that a number of people contributed and worked on. Special call out for Raul and David and others who like poured a ton of time and energy into producing this, and many other people, of course, that I'm probably forgetting. I'm going to have a number of QR codes in the talk. If you're interested in those links, you can like grab a snapshot, or if you're watching this on YouTube, you can use that. That way, you don't have to like take a video and like type things. Somebody asked for me to do this, so great. This roadmap is awesome. So if you're new to the libp2p project, or even if you've been around for a while, make sure to check back on this, because this gives you a sense of the scale of ambition of the project in terms of what we would like this project to be able to do or be able to support and so on in the long term. There's an enormous amount of stuff here, and it sort of like reads like people sort of describing like fundamental computing infrastructure like operating systems or programming languages and so on. And it is meant to be that way. This is the scale of what libp2p can be. But there's a lot of work to do to get here, and so that's kind of what I want to talk about today. So why does libp2p matter now more than ever? I've talked a lot about this in other talks, so I'll only touch about it briefly here. Today, the internet is one of the most important things about humanity. It has become this sort of nervous system that mediates all of our interactions. And the properties of that system, the properties of the networking protocols and the computing architecture that we're using, those end up defining our rights in the world today. Whether or not a computing infrastructure lets you send messages to other people, whether or not it lets you publish blog posts or other articles or other kinds of information, whether or not it lets you video call somebody and so on, whether or not it lets you store data and recall it later, your personal data, your personal files, all of that kind of information. So if you think about like your life day to day today and all of what you can do thanks to computers, remember that at the end of the day, all of those applications are mediated by the internet, and for the most part, and the properties of the internet underneath the hood define your future ability to continue using that. And so there's a lot of people around the world that have encountered moments where suddenly the internet doesn't work for them anymore for reasons, for various different kinds of reasons. So it's really key to kind of in this moment, as the internet has is still diffusing in the world, we're still kind of evolving the platform to now work pretty hard to embed digital rights into the network stack. This is only going to become more and more and more important as things like AR and VR hit, as things like the metaverse scale, as things like brain-computer interfaces come in. At that point, that becomes like a much more serious moment when suddenly your brain is directly hooked up to the internet. Like that's gonna greatly increase the importance of all the security properties of the network. We also happen to be in a pretty critical century. There's a lot of stuff coming in the future decades. So things like existential risks and so on. And though human life has gone dramatically better over the last few centuries, we kind of have inadequate macro systems that are going to kind of struggle with the ongoing challenges of the century. And there's a high need for something that can prevent kind of like an Orwellian internet developing. We're already starting to see the beginnings of this in many countries where different computing platforms are getting used to track people, to implement social systems that control behavior and all that kind of stuff. And that's just the tip of the iceberg of, actually, it's the tip. It's like a distant picture of the iceberg that exists in the future. And so I think we're in time. We probably have a decade or two, and we're in time to radically improve the properties of the internet to prevent those kinds of features from developing. Therefore, it's pretty important to work on these things. You're like, well, this is heavy. This is like a ton of really impactful stuff. I thought we were going to talk about like libp2p protocols. Well, yeah, so Web3 is about these kinds of challenges. And at the end of the day, Web3 is about a set of values and trying to embed those values into the network stack. And think of those values translating into specific kind of protocols. So if you build a peer-to-peer protocol that enables secure messaging, you're embedding a right like freedom of speech into the network. If you build a protocol that enables secure publishing, the same thing. If you can build things like privacy-preserving routing systems, that is a critical property to prevent those kinds of Orwellian internet outcomes. And so libp2p is key to all of these kinds of systems that we hope to create. Because libp2p creates an entry point by which you can try to develop a bunch of these kinds of systems and deploy them into the network, test them out, improve them over time, and then let them be adopted at scale. Great, so hopefully I've convinced you that it's pretty important to both improve and develop libp2p, but also develop a bunch of new systems building on top of this. So think of trying out all kinds of important improvements to the network stack and use libp2p as a platform to deploy those. Great, so let's talk about the macro context around the libp2p project. So like I mentioned, it's used by a ton of different ecosystems. Tons of the developers rely on systems that are adopters of libp2p. So there's an enormous amount of downstream users. And a lot of these users also are entire protocols or entire businesses and so on. So there's an enormous amount of growth and value downstream of the libp2p improvements. And a lot of those projects and systems care about these kinds of systems and care about these kinds of protocols, and they want to develop those things. But right now they're sort of lacking good venues by which to create those improvements. The entire Web3 space also has to reach the level of quality and maturity to be able to deal with the Web 2 type of workloads. Web 3 right now is tiny in comparison to Web 2. Web 3 is tiny in comparison to Web 2. This is where we're headed. We're headed to systems that can deal with this kind of scale, this kind of magnitude of application. And if we want to bake in those rights meaningfully, we have to be able to deal with this kind of magnitude of scale and performance and so on. This is way, way, way harder than what all of the blockchains are dealing with today and so on. So going back to the roadmap, you can think through a lot of these things that we're describing as embedded within a bunch of the pieces described here in the roadmap. And all of this is, of course, not well ordered in terms of we can follow a bunch of different paths towards those goals. And I think it's really key that as a group and as a broader community, we kind of distill this down into some kind of ordering in terms of leverage. So before we can do a lot of these things, we have to grow our community, we have to grow our contributor base to be able to tackle these kinds of things. Great, so I want to kind of touch on a few things to work on, and the last one is going to be scaling the libp2p project, and I'm going to spend most of the time talking about that. Great, so I'm not going to focus on features individually. You've probably thought of many features to improve on for the last couple of days, as many people touched on a lot of things here. There's already a lot of important, valuable improvements coming downstream of that. I want to touch a little bit on new protocols. So these things, there's tons of papers already existing for the last 20 to 30 years of R&D that describe many different architectures for these kinds of protocols. Often what we need is just to do a literature review, find a really good paper, and then implement that and deploy it out in a scalable way to users. So we don't have to get stuck with just the current implementations. Sometimes what we need is a new protocol, a new system. So we have one DHT implementation, or there's many DHT implementations in libp2p, but one of them is used primarily, and that was like the basic default Kademlia that we started with for IPFS. The goal in IPFS was to actually implement Coral with some Kademlia improvements. We never got there because we got distracted by a bunch of other things to do. But those kinds of things are important improvements that somebody could go and take on and do. Actually write an implementation of Coral, or start with better DHT implementations, so things like 1OW and others. Like there's been tons of DHT R&D since Kademlia that hasn't made it into the libp2p project. And like that, you can probably look at any single major protocol type within libp2p and find awesome protocols that have been written about, sometimes implemented, so sometimes you can take implementations and adapt them into libp2p and plug them in, oftentimes rewrite them. By the way, I do think the move to something like Wasm so that we can implement once and run everywhere, like that would be really, really cool and awesome. Or implement once, run everywhere until it becomes a performance bottleneck. Then at that point, you write in your own language or something like that. That could be a really good direction. And also a plug for things like Fluence, where if you can get to a mode where you can start writing libp2p protocols in a distributed computational language so that you don't have to write 7 implementations of a protocol, and in each one of those, write a bunch of pieces of code that have to interact with each other and so on. If we throw programming languages at the problem, we could probably scale up the level of work that we could do across these kinds of systems. So those are all really, really good directions. Yeah, so one thing that I think could be really useful is for somebody to go through this roadmap and look at these kinds of things and map out what are the candidate awesome systems out there that we could be developing and implementing in these kinds of to achieve these kinds of things. Or oftentimes what these things require is entire teams dedicated to those kinds of efforts. So for example, libp2p and IoT is way harder than mobile. We've spent the last 2 days talking about how hard mobile is. IoT is even harder than that. You have way worse power constraints, way worse bandwidth constraints, and so on. And if you want it to work in something like that, you then are very likely to need a specific implementation for that. So we kind of also have to get into a mode where we can help generate entire teams of people going towards these kinds of use cases, owning different systems or implementations. Which takes me to distributions. So in the IPFS project, we use this kind of sort of upgrade paths for the browser, for OSs, for mobile, and so on. And I think it would be great to start doing the same thing for libp2p, but add a measure of performance and optimization to it. This is mostly in IPFS, does it run, as opposed to does it run really well, or are there a ton of applications depending on it? And so it would be really good to create some kind of view of roadmaps across the different platforms and get a very strong sense of how well it works in that platform, have feature sets that we can start comparing against, and ideally tie it to benchmarks. You can see oh, here's how it runs, here's how various implementations run in mobile, and there's a benchmark you can run, and you can see it. And just remember that the world of computers is very large, and there's constantly going to be new devices with different constraints and so on. And so we want to get to a network stack that we can evolve to fit a lot of these constraints. The good news is that the entire Web3 world, because it depends on libp2p, it's going to drag libp2p into all of these places. We just want to kind of focus the attention of a lot of those folks to help us develop a lot of the tooling and a lot of the systems and so on. What we're missing is some coordination, and I'll get to that in a moment. Another note on optimizing performance, you get what you measure, always. So it's really important that if we want to achieve certain kinds of outcomes, we measure them regularly and clearly. So just to set benchmarks, like look at projects like programming languages or browsers. These teams are like both massive in terms of scale. Like I think the Chrome org at some point was like thousands of people. I don't know what it is now, but these systems have extensive tooling to measure every single little aspect that matters in those pieces of software to be able to measure how certain improvements are doing against those things. So, and one of the key things here is to invest in like real-time CI for every single change set that you might do, because that's what tells you whether or not you're making forward progress towards like some good outcome or not. And so getting to this kind of thing requires a lot of work and effort. It's been awesome to see all of the improvements towards this. So one really important improvement that we did, I think, a year or two ago was TestGround, which enabled a lot of measurement that is now was an important tool that landed in our community to be able to kind of try out a bunch of these kinds of systems. From that, there's been a number of important pieces of work that like have generated several improvements that have just kind of been deployed and then improved performance for everybody. And I was super excited to see all of the work coming out of the Network Observatory. Like, this is awesome. And what I love about it is like the data is super robust, and you can like clearly see what's going wrong. And the kind of like very well articulated opportunities of saying, oh yeah, like here's like a very concrete opportunity. Here's the deployment. Here's like the performance out of it. Great, let's ship that improvement. And I didn't manage to get like snapshots of a lot of the other talks today and yesterday, but there's been an enormous amount of focus on performance and optimization in the last 2 days. I'm super, super excited about that. I think like this is totally going in the right direction, and so full speed ahead towards all of us. So one thing that I would love to kind of like fix over time is that benchmarking and optimization for libp2p becomes so like very clearly a thing that a lot of our community is doing. And so for that, I have like a little test that I describe as the Google image search test. And this comes from the fact that image search these days is better than text search. You can get a like really good sampling of what something is by running it through image search test. So for example, NFS like clearly has a lot of benchmarks. A lot of people have been thinking about this problem and writing reports and so on for ages. When you have a performance benchmark in 3D, you know that a lot of people have worked on it. Golang, tons of performance benchmarks. A lot of work has been going on there. WebRTC, clearly a protocol that a lot of people use and struggle with because a lot of people have been working on trying to optimize it. Web transport, clearly a new protocol, right? Like people haven't really begun to really push it or try to figure out like how well it performs. Ethereum, even the Ethereum protocol has a bunch of benchmarks. You can also measure like the hype of a protocol by like the number of pictures of like coins that show up when you try to look for benchmarks. IPFS, this is awesome. This is great set of benchmarks on there already. This probably wouldn't have been the case 2 years ago. So 2 years ago, we probably wouldn't see a lot of these. libp2p, we don't have a bunch of benchmarks out there. Probably like part of that is SEO because there's a lot of really good results so far. But I think part of it is like just writing reports of this stuff out and having this kind of like continuous deployment type of thing that we can see. So it'd be really, really awesome if like, I don't know, a year from now or 2 years from now, we can do this like image search test and like get something close to like this or this. And I think that would be, like if we get to the mode as a community where we can do that, that'll like just fix tons of problems along the way. Because tons of human time is spent running and rerunning benchmarks or thinking about problems instead of just being able to see a diagram and be like, oh yeah, that's the result, great, let's move on. So really put the computers to work for us. Cool, so I'm gonna skip improving product. I had a bunch of thoughts there, but let's jump into scaling the project. So I think one really useful, valuable thing that we can do in scaling the project is kind of invest a bit of time and effort into our communications tooling so that it's a lot easier for people that are interested in working on these systems to learn about all of the awesome activity that's happening. So the work that we've been showing over the last 2 days shows a super awesome track of work in a bunch of different directions, but it's probably really hard to find that right now from the website. It's kind of hard to discern that that's happening. And there's probably a lot of explainers that, like the Post-op explainer is beautiful. I don't know if you've ever seen it, but like it's an awesome explanation of the protocol, and it's super useful. And I've heard a lot of people describe things about gossip sub or pub sub that literally come from that explainer. And so it'd be really, really awesome to then arrive at those kinds of explanations for a number of the other protocols that we use. And I think another thing that would be valuable is kind of investing some time and effort into the community. So the community management side of things, which is helping create a more present space in terms of like forums and chat and so on to enable a lot of people that are interested in these kinds of systems to come work with us. So there's like a this XKCD image that reminds me of libp2p a bit. So you've probably seen this kind of thing. It's like this great comic where, you know, like this was written, I think, after the SSL hack from a long while ago, where, you know, an enormous amount of digital infrastructure sort of depends on a small project. And when you sort of like really break that out, there's a ton of work and effort that goes into maintaining any kind of well-used open source system. So there's like funding that has to go into it. There's lots of people that have to work on a thing. There's organizations involved to be able to deal with all kinds of things that projects might need. There's a ton of work that goes into coordination and coordinating all of the people working on things and all the organizations and so on. Then from there, you like actually have to do the work. You have to do a bunch of research to figure out like what you're going to do. You have to put that research into work. You have to develop things. You have to develop software. You have to develop tooling for writing software. You have to develop a system to optimize it and so on. Then from there, you can get to productionize it. Like, great, you have the thing. You know what you're going to do. You have the thing. You build the thing. Now you got to like optimize it and refine it and stress test it and so on. And you get a ton out of that. Then from there, you have to like put it into a really nice, good UX form where you're going to create a product that people can use and have a great experience with. From there, you get into like deploying the thing and marketing the thing to the world and so on and telling the world about it. And so there's an enormous mountain of work that goes into, you know, well-organized R&D. And then you get into maintenance, which is an enormous amount of work too, which is like you have to fix bugs in a ton of different pieces of tech. You have to deal with like ancient systems that are unrelated, potentially causing problems in the open internet. There's all kinds of improvements that people want. There's security things that come up over time. Sometimes like some library somewhere has a security fix and you're like, oh, damn, now I have to go and update like every single thing that appears out of that. So all of these software infrastructure projects require kind of dedicated teams working on maintenance. And then after all of that, you have to like invest time and effort into growing and maintaining the community itself. So there's an enormous amount of work that goes into open source projects. And each is necessary, but not sufficient. So you really need kind of like a well-distributed amount of effort into all of these things. And so when you think about like libp2p, you know, so you can think of like the entire Web3 world like relying on libp2p somewhere in there, even if the projects don't adopt libp2p. So you enter a condition where some blockchain somewhere that didn't use libp2p is interacting with some other contract somewhere else in some other chain that does rely on libp2p. So that means that then now all of those things are now dependent fully on libp2p continuing to work well. And I don't know if this is a misestimate, but I think there's somewhere between like 10 to 50 people working full-time on libp2p, maybe less, at different points in time during the year. And there's about 5 organizations that like are very, very focused on it, and maybe about like 15 organizations that are tangentially focused on it. And there's been a ton of work and effort that we've been putting into it, maintaining it over time. And when you think about like, hey, great, so like, I'm hearing this message of like all of Web3 depends on libp2p, and somehow there's a lot that we want to do, and we're constrained. What are we constrained by? So it's not funding. So normally in a lot of open source, funding is usually the problem. Like if you go back to the OpenSSL problem, like just it used to be that in Web 2 it was hard to motivate people to invest in open source, in maintaining open source. That's not the case in Web 3. In Web 3 we have a ton of funding. It's really like people invested in working in the projects. It's organizations willing to commit and dedicate their time and effort into working on the projects. It's coordinating all of those groups to work on things that matter. And I think in terms of the R&D, like we're doing way better in a lot of things, but I think right now, like the development and productionizing area is probably where a lot of things get stuck. And I think that that's where we need a lot more attention. So if you're like interested in peer-to-peer systems, interested in contributing to this stuff, excited about libp2p, come into that area. And I would say also the coordination angle. If you want to work on the project, helping the project coordinate, helping people across organizations coordinate, I think would be extremely valuable. And then on maintenance, people helping maintain open source projects, there's a ton of different libraries across libp2p that can give you a ton of experience on how to develop and refine software and how to work with a lot of different groups. So libp2p is a great project to get involved in and definitely has a high need for really brilliant people working across the stack. And so when I think about like, I'll talk more about this in a general sense in a moment, but when I think about like open source contribution structures, there's like this pyramid that a lot of people use, which kind of describes, you end up with this like pyramid of contribution alignment where like you start with new users at the bottom, and then from there they like become experienced users, from there they potentially become contributors, from there potentially become developers, and from there potentially become maintainers. And at each one of these stages you have like, you need an enormous amount of knowledge and motivation and interest and time and so on. So you end up with like a very low conversion rate from each one of these to the other. And there's great graphs over time that sort of show that as projects scale and impact, you very much end up with this kind of like contribution pyramid. I like to think about it upside down, because it's like all of the users at the top are like deriving value from like the experienced users and contributors and so on all the way down. And if like the pyramid gets too big and like it doesn't have like a good base, then it'll like fall over, right? So I think like libp2p is sort of like here now, where like there's very few people contributing it, and there's just a massive surface area of people using it, meaning it's like stretched sideways. And where we want to get to is like something like this, where we're both growing the number of users over time, but we're growing the number of those users that become experienced users, that become contributors, that become developers, and eventually become maintainers. So I think like helping make this transition is probably one of the most impactful things you can do in the libp2p project, or actually one of the most impactful things you can do in the entirety of Web3. Because if we go back to this picture, by improving libp2p, by creating this as a better, more robust platform, you can then improve all of the goals of Web3, and you can potentially get to create an infrastructure to be able to actually tackle these kinds of problems, right? So getting to something like proper reader and writer privacy, preserving publishing systems and so on, which is like what the entire Web3 world wants, is only going to become possible if we have the large-scale, robust systems that can deliver platforms like that actually fit the performance requirements and needs of the Web2 world, but with Web3 properties. Great. So how are we going to do that? I think we need to systematize this. We've done this in the Filecoin project, and it's been tremendously successful. So I think we need to like think through the sort of like conversion pathway for people entering the P2P world. This is kind of like a builder's funnel for the Filecoin ecosystem and for IPFS and so on that was very focused on people building applications. So there's some equivalent version of this, which is really a funnel of like helping generate developers and contributors to libp2p as a project. So we should kind of create something like this that help us understand how people are arriving in these projects and so on, and getting the support they need to become to really develop in this world. This funnel kind of uses things like, and again, this is very oriented towards building applications, but think about like using hackathons as a venue for people to learn the tech, and then enabling people to lean into things like microgrants to get some resources to be able to work on their application, and then from there going into like potentially larger grants that really give them time to recruit a team and build a team to go after that, and then from there go into accelerators and investments and so on. Again, this is very tuned towards applications and people building businesses and so on. So we should create an equivalent version of this that supports developers and teams of developers and researchers and so on that want to do a lot of this P2P systems research work to contribute to libp2p. And so I would love to kind of like, I want to be putting some time and effort into helping think about this, and if you're excited about doing this, come chat with me after, into kind of like how to generate the kind of ecosystem growth that we had in the Filecoin ecosystem and sort of bring that to libp2p. I think one great place to start with is hackathons. Today, there's a lot of different projects running all kinds of hackathons. It'd be great to bring libp2p in like full force to a lot of these and enable people to kind of like try their hands at building something new, not just an application, but really some new component to libp2p. So for example, potentially having a P2P-oriented hackathon specifically around like, hey, let's implement existing DHT protocols and try them out, and then benchmark them and see how they go. You could have a hackathon where like everybody writes some DHT implementation, and then you measure the performance at the end of the day, and like you have some metrics that you can like, some test suite that you can run across all of them. You know, things like that are going to both give people experience with programming these kinds of systems, and are going to kind of push people towards learning the very complex dynamics of like programming these systems at scale. And so from them, we can like build a much greater knowledge about how to make these systems, so that from there we can hopefully like nurture and develop into people and teams that will take on these kinds of this kind of work. I want to do a bit of a segue on public goods, because you know what I've just mentioned is like, hey, sounds like a lot of work. How are we gonna fund it and coordinate it and so on? In a lot of conversations over the last day or two here, it strikes me that a lot of people in this community, especially in like the peer-to-peer world, could benefit tremendously from the public goods orientation that the crypto community has been getting into in the last couple of years. So libp2p is open research, open development, open source software, public infrastructure, and it's a community. And this is basically public goods. And really, libp2p is a lot of public goods. It's not a single thing. There's a lot of different components that go into it. And it's made by a lot of people and organizations. And you know, just a quick summary of public goods, like they're meant to be non-rivalrous. So that means if somebody benefits from the good, you know, it doesn't reduce the amount available to others. It's classic open source. And it's not excludable. If you use it, the people provided the good. You can't stop people from benefiting from it. And it's a classic open source problem as well, where you get the free rider problem. And so this is kind of like the world of public goods. The crypto space in general is becoming extremely good at reasoning about these systems and building infrastructure and tooling to enable the funding and coordination of these kinds of systems. Funding is not really a problem. It's more about how do you orient the funding to achieve results that matter for a community, that matter for a commons, that matter for the end users of a public good. And that's where often a lot of things sort of like fall apart. The good news is that the Web3 space in the last couple of years has been developing a lot of really good work towards building infrastructure and tooling for doing this kind of public goods funding. And a lot of it is sort of happening under the memes of like, hey, funding public goods, or funding the commons, or Shelling Point, or the Green Pill movement, and so on. So I want to kind of like take a brief foray into that world, because I think like many of you might find it really refreshing, and that might help us like come back and then orient the libp2p community towards some of that. There's a talk I gave called Crypto Econ for Good at ETH Amsterdam last week. Here's the QR code if you want to check it out. This is sort of like a little excerpt that I got from there. And that's also an excerpt of the Green Pill book, which you can get, which is I think very, very, very useful. So take the green pill, Anon, and this comes from like the Matrix, blue pill, red pill. The TLDR of the whole green pill movement is that we're facing these massive scale coordination failures and coordination problems. By recognizing that most of our problems at massive scale come from that coordination failure, and recognizing that we have a bunch of tools in economic theory and distributed systems and networking and so on to build structures and mechanisms to solve coordination problems, you can put those two together to create systems that are regenerative, not extractive, by using economic theory and economic mechanisms to warp the incentive fields to produce the outcomes you're looking for. So what does this mean? Like, hey, tons of problems out there, especially the coordination of how to produce public goods, how to maintain public goods, and so on, are really about coordination failures. It's all of this sort of comes from people not agreeing what the right things to do are, or who's going to do them, or who's going to invest the time and effort into it. And there's a broader meme on the internet around kind of like very clearly articulating this coordination failure as like giving that a face, because humans tend to operate way better when you can create like an identity for an enemy. And so there's this thing coming from the Meditations with Moloch essay to kind of like create this like demon god of coordination failures, Moloch. And the point is to like create coordination systems and tooling to beat the coordination failures. And so the Green Pill movement is about developing the thinking and impetus and memes and excitement and so on to get a lot more people thinking about these massive scale problems as coordination failures, and to then equip those people with a lot of tools and systems and programmable money, programmable incentive structures, and so on to create structures and create better systems to actually defeat those coordination failures. So this whole movement is about public goods. It's about figuring out structures to create systems and mechanisms and so on to incentivize their structure and to incentivize their thriving and so on. And it's grounded on leveraging cryptoeconomics. So that means leveraging the knowledge that we have about how cryptographic systems work, leveraging the knowledge we have about economics, about broader social sciences and political science, game theory, get like really robust about the protocols and so on, and through that lean on some programmable incentive machine like a blockchain and so on to coordinate work. And the broader goal is to kind of create this regenerative cryptoeconomics structure that where you can lean on systems that over time are having positive externalities that are regenerative, they're not extractive. And so a lot of it comes down to thinking about the landscape, measuring the landscape, getting a sense of what the problems are in some incentive structure, and then using mechanism design to warp the incentive field to coordinate people towards a better outcome. And so that usually translates into things like funding distribution mechanisms, so things like quadratic funding and retroactive public goods funding, or DAOs that orient towards certain kinds of work and so on. One really cool structure recently is an aqueduct that comes from the Gitcoin community, where protocols are going to deploy some fraction of their tokens and so on towards projects that are critical to their development. So it's like an explicit way to drive funding of public goods. And there's a whole world of mechanisms, of course, like many different kinds of tools and systems can be used to sort of create this kinds of incentive structures. So where all of this sort of like comes into play in the sort of like libp2p world is that what we can get to is to use these tools and these mechanisms to coordinate groups of organizations and groups of people towards solving those kinds of problems and those kinds of systems. Let me get to how I propose doing this. So a lot of this comes into doing science and technology translation and doing deep R&D work. So now that I took you through like the region Green Pill movement, and by the way, there's like a super interesting community, highly recommend you like page into this stuff by either like checking out the podcasts or books and so on. Let's get into accelerating progress. So at the end of the day, there's this massive incentive coordination breakdown going from science to technology. People have been producing a lot of amazingly valuable work, thinking about what to do, producing really great results in terms of the things that we should be doing. But a lot of times those ideas get stuck somewhere. There's a hurdle going from really good science to implementing the technology and getting it deployed into the world. The market in general, once you have something that looks like a product well enough that can be scaled, the market is extremely good at taking that and getting it to be diffused into being used by billions of people and so on. So the gap that we need to close is this R&D gap of going from what we already know is like a really good idea or potentially generating new ideas and getting those turned into systems and devices and so on that could eventually be put into products. And libp2p sits squarely in this environment. At PL, we tend to think about this as an innovation network. You have to involve lots of people, lots of organizations, lots of work, and you want every single artifact generated here to be maximally useful to as many people as possible. You want it to be open source, you want it to be leaned on, and so on. And you can think of a lot of the stuff that we're talking about in terms of libp2p as sitting somewhere in this pipeline. Either it's new research, new work, new fundamental exploration of some new protocol, or it's implementing an existing protocol and producing a good library that implements that system, or it's actually optimizing it. It's measuring it, characterizing it, provide improvement proposals and so on to get it to perform better, or it's refining its tooling or system so that it can be used and put into a product. So libp2p is like a quintessential example of sitting in this R&D part of the pipeline. So the whole public goods funding world is sort of like trying to generate some environment where we can sort of like equalize the public funding structure or like staircase of funding. When you think about VC and so on, the reason the market works extremely well is because there's robust funding at all these various scales. And in the public goods world, it's not so much the case, especially once you get into the larger amounts. If you're trying to do large-scale R&D, large-scale science, and so on, there's not that many funders, and there's not that much money, and so on. But the good news is the crypto space is actively trying to work on this kind of problem. And I predict that somewhere between 5 or 10 years, we're going to see we're going to see crypto networks funding R&D at the scale of nation states, and that's going to be like a really, really compelling thing. So open source software, libp2p, and so on are public goods. There's really good theory developing over its production system and so on, and how to make it. And a lot of this kind of public goods movement and so on is generating many different kinds of mechanisms that we can use to fund these kinds of structures. So I'm telling this community about this and putting it in the context of libp2p to encourage a lot of people to lean into these kinds of mechanisms to help support individuals, groups, and organizations and so on to help develop a bunch of the tooling and systems that we need in libp2p. So that might be research work early on. It might be like helping align funding for research groups, or it might be helping align funding for entire teams of developers, entire companies, or entire DAOs or nonprofits or something to focus on some part of the stack and help develop it and so on. There's a lot of really useful exploration of mechanisms. I don't think there are like really good mechanisms yet to incentivize maintenance. This, I would say, is like an area that really needs good ideas. There's a great talk from Pooja on this, the QR code's there, that goes into a bunch of the experiments that are being run right now, and she gives a bunch of good ideas at the end of like what new experiments could be tried. We need a lot more good ideas here, but to just give you a sample, you can think of creating systems that do credit attribution on who's contributing to what projects and so on. You can use that credit information to help drive funding decisions, either to give those people funding or to enable those people to decide where funding should be deployed. Meaning you have an algorithmic way of detecting who are the contributors of a particular project, and then you can give them the decision-making power over other funding to see what they would like to fund and so on. Quadratic voting is one such way of doing this, where this is a structure to get a community to allocate shared pools of resources. There's things like vesting contracts being explored, maintenance, DAOs, and so on. I think these are very early. We'll see what comes out of these. There are things like the S process, which is a structure for enabling a few people that have a lot of decision-making power over funding to delegate their decision-making to a group of experts, domain experts that have a really insightful view of how to allocate the funding. So you could use something like this in the libp2p community to take things, organizations like Protocol Labs and the Filecoin Foundation and the Ethereum Foundation and the Web3 Foundation and so on, to be kind of like the funders at the top, and have them delegate, create a community treasury for libp2p, and have them delegate the funding decisions to all of the libp2p contributors, researchers, developers, and so on, to then decide what projects to fund. So over time, like, we can play with a bunch of these mechanisms. We can see which ones work. We can see how these can help grow the community, and then over time kind of select which things can work for us. So the broader view is like, hey, let's have the libp2p community learn about all of these tools and use them, because they're precisely created to sort of help this kind of system. libp2p has had a little bit of experience with grants. So we've done some amount of dev grants in the past. There are some new ones that were talked about in the last couple of days. But really, we should be having hundreds. We should be able to get to a point where we can run lots of different grants for building a bunch of the different tools and systems that we need. We also don't have anything on Gitcoin yet, which has a huge community in Web3 that could potentially participate. So this is like a great opportunity. Like somebody here could help articulate things that we could work on, or that people could work on Gitcoin, and Gitcoin already has implemented all the quadratic funding structures and all that kind of stuff to be able to vote on what are good improvement proposals and all that kind of stuff. So if we can like put some effort into leaning into these systems, we might get to really scale the contribution. So I want to end by sending out a community poll that I want to kind of like give to this group first, and I'm going to kind of like let everybody here tell us what you think first, and then I'm going to share it out to the broader world on Twitter next week. So yeah, if you can go there and just take a couple of minutes to respond, that would be super useful to me. Okay, feel free to keep finishing while I continue. Thank you so much for your input and your feedback. It's going to be super useful, and it is going to direct some amount of effort for a number of people over the next few months. Great. So with that, that was all I wanted to talk about, the long-term view of libp2p. It's a project that really matters. It's a foundational tool for all of Web3. There's a ton of people that depend on it. A lot of people want to support it and fund it and so on, but we're missing coordination primitives to help organize people. And there's a ton of exciting problems to work on, all kinds of really valuable R&D that could be done, or kind of really good systems that were talked about in the literature that could be put into action. And we're really just needing more people to help work on those, or to work on the systems that enable those things like deep performance testing and optimization and measurement and so on. Great. With that, that's it. And last plug for going to read the roadmap, because there's a lot of really, really awesome projects and ideas in here. Cool. Any questions?
Awesome presentation. Unfortunately, I guess there's a bunch of questions. Unfortunately, we can only take one. Technical reasons, don't ask. We'll do better next year. So who really, really, really thinks he has something to put Juan Benet in difficulty here? And nobody. It's your time to grill. Okay, don't let me ask the question, please.
I think you scared everyone by saying one question.
Yeah. Okay, I'm gonna ask it. Fuck it.
Go for it.
Juan Benet, you have this super ambitious roadmap, like supervision, but what are you really afraid of? What keeps you up at night, like?
What am I afraid of?
Yeah, like really worries you.
Yeah, this slide. There's these massive existential risks that the species is facing, where things like climate change. This might not be an existential risk, but it's a serious problem. Nuclear threat, biotech, and engineered pandemics being much more likely over the next 30 to 60 years. And then this, like screwing this up, so the computing phase transition is, when you think 80 years back into the beginning of computing, and you think of like decade over decade, computing systems evolving and delivering many new kinds of improvements, and you think about humanities today, 80 years after that, and how much computers have radically transformed our species, and you just project those 80 years forward in the future, that's enough time for a much greater transformational change that will come from things like AR and VR, robotics, brain-computer interfaces, AGI, and so on. I think AI risk is a pretty serious thing where I think 10 years ago it wasn't 15 years ago it wasn't taken seriously, 10 years ago it started being taken seriously. And most expert opinion at the time was like, oh, we'll probably have AGI somewhere between 50 to 300 years. Now that same group of experts is thinking somewhere between 10 and 50 years, which is a really aggressive shrinking of the timeline. And that I think is a very, very, very big risk. So yeah, and probably like the fact that our macro systems aren't equipped to address these things. So yeah.
Thank you very much, guys. Juan Benet, awesome talk.